According to the National Health, the U.S. men have mean 4 pounds and standard deviation 8 pounds. We're designing an elevator that will accommodate and will safely carry up to 8,100. Question 1. The distribution of the averages is in words. In words, we're talking about the average weight of adult U.S. men in a random selection of 40. So, X bar is the average weight of a sample of 40 adult U.S. men. The distribution averages fits what distribution? Well, it's normal. The central limit theorem says it's normal, and the mean is equal to the mean of the underlying distribution, 194, with a standard deviation equal to the underlying distribution divided by the sample size. So the underlying distribution has a standard deviation of 68, so we have 68 divided by the square root of 40. Would it be unusual for a random selection of 40 adult U.S. males to exceed an average weight of 203 pounds, the maximum safe average for the elevator? Well, to find out if it would be unusual, we should calculate the probability. So in number 3, we're looking for the probability that the average weight exceeds 203 pounds. So that's 1 minus normal, 194, 68 over the square root of 40, and 203. So let's ask GeoGebra about that. So we have 1 minus normal with a mean of 193, standard deviation of 68 divided by the square root of 40, and 203. I'm not quite right. The mean is 194. Let's try that again. 194. So 0.2012. So there's about a 20% chance of this happening. So no, we shouldn't be surprised. I mean, it's more likely that it wouldn't happen, but 20% chance is decent. So we're going to say no. It's not surprise. It would not be unusual. It would not be unusual. Would not be unusual. Number 4. Calculate the 99th percentile for the average weight of 40 U.S. adult males. Okay, I'm going to use a picture to help here. What we're talking about is the 90th percentile. So the distribution of the averages has a mean of 194 with a standard deviation of 68 divided by the square root of 40. Let's find out what that is. 68 divided by the square root of 40 is approximately 10.75. So we'll just call it 11. It's good enough for our sketch. So here at 1 standard deviation we have about 205 2 standard deviations is about 216, and then 227. So the 99th percentile we expect is going to be somewhere around here, because 99% of the area under the graph has to be to the left of that number. So the 99th percentile, but again, this is just a guess, so this is just an estimate. So we're going to ask GeoGebra, the 99th percentile is the inverse normal with a mean of 194, standard deviation 68 over the square root of 40, and probability of 0.99. So if we ask GeoGebra for that number, we will have it. So this is inverse normal. Mean is 194. Standard deviation is 68 over the square root of 40. And the probability 0.99. So 219.01, so we'll just call it 219. 219 pounds, that's the 99th percentile. Number 5, based on your answers above, are the engineers designing a safe elevator? And why? Or why not? So, number 5, well, there's a 20% chance, according to number 3, there's a 20% chance that a group of 40 males will exceed the maximum safe capacity. That's not good. That's not safe at all. And here in number 4, there's in the 99th percentile for the average of 40 U.S. adult males is 219 pounds. So if they made it safe for up to 219 pound average, then there would only be a 1% chance that a group of 40 males would exceed the limit. And assuming that the average size of females is smaller, then this is not likely to happen, because chances are good you're not going to have 40 men. If the elevator had 40 people at all, it would be a mix of males and females, you would assume. So what we can suggest is that we recommend building it so that it's safe for an average weight of at least 220 pounds.